Hello, Algebra 2, and welcome to section 11.2, where we're going to start to talk about probabilities. So today our learning target is to find probabilities in the theoretical realm, experimental probabilities, and talk about simulation methods. So first we have experimental probability. Experimental probability is probability that is calculated from an experiment. So your probabilities are going to be represented with a capital P, and then inside parentheses, you're going to have some event that you are testing to see its probability of occurring. Then your experimental probability will be event occurs, the number of time the event occurs over the total trials, the total number of times that you do the experiment. So in problem one, we can look at a sports example. So sports use a lot of statistics, and you can calculate probabilities of certain things happening. Like in basketball, you can calculate a free throw percentage, which is the probability of making a free throw. So here, Sarah makes 12 free throws out of 20 attempts. What is the experimental probability she'll make the free throw? So we are calculating the probability of a make, and she made 12 shots, so that's how many times the event occurred, and then the total number of trials would be 20. That's how many times she did the experiment. Then we'll take and simplify that down. That would simplify down to 3/5. And that could also be written as a decimal 0.6 or as a percent, 60%. Experimental probabilities then can be used to predict other occurrences. So for example, using this experimental probability, we could set up a proportion and start to figure out if she's made 3 out of 5 shots, how many shots can we expect her to make out of 25? And we can do a little cross multiplying and dividing and figure out that x would need to be 15. So you can use it to predict other calculations. So based on her experiment, then we could expect out of 25 that she would make 15 total shots. Our second type of probability is a simulation. So a simulation is a way to model random events such that the simulated outcomes closely match the real world outcomes. So sometimes there's a case where you don't have the resources to do an experiment, or you don't want to waste materials by doing an experiment, so you can use a simulation with technology to predict what the actual probabilities would be. So in problem 2, we are going to simulate guessing answers on a test and then see what the probability would be that we would pass the test by getting more than 5 correct. So on a multiple choice test, each test has 3 choices, but only one choice is correct. How can you simulate guessing the answers? And then what is the probability that you will pass the test by guessing at least 5 of 10 answers correctly? So how can we simulate guessing the answers? We can use what's called a random integer generator. So we can simulate the answers to the test being 1, 2, and 3. So that would be like A, B, and C. But we're going to say anytime a random 1 comes up, that would just be like randomly guessing the correct answer. Anytime a 2 or 3 comes up, that would be randomly guessing an incorrect answer. And then we're going to make it so it's 10 total numbers, and then count how many times we got a correct answer and then how many times we got an incorrect answer. So we're going to head to our calculator here in a second and use this random integer. To get random integer, you're going to hit math, then you're going to hit probability, and then you're going to scroll down until you see random integer, and that's going to produce those random numbers, which we can start to simulate. That would be us guessing answers and then checking to see how many times we get the correct answers. So we'll head to our calculator now, and then we'll kind of periodically going back to our notes and checking in on what our probabilities are. So on our calculator, you're going to hit math, and then you can go over to probability, and we're going to head down to number 5. So depending on the version of your calculator, you will have to input your numbers a little differently. So for the newer versions of the calculators, you're going to give an upper and lower value of number that the calculator will randomly generate. So we're going to go 1 to 3 because we have 3 options on the test, that the multiple choice test, and then the total number of numbers we want to generate is going to be 10. Then you're going to hit paste, and it's going to bring you back to your main screen. Now, if you have an older version of a calculator, when you select random integer, it'll bring you to this main screen. You're just going to hit 1, and then you're going to hit the comma, which is above 7, 3, comma, and then you're going to hit 10 to tell it to do 10 numbers. And then you can start to generate your random numbers. So we'll hit enter, and you're going to get a set of 10 numbers. So this would be us on a test guessing. This is wrong, wrong, correct, wrong, 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 correct, wrong, wrong, correct. So this one we only got 3 correct. So when we're heading back to our notes, we would mark that as a test that we did not pass. So we'd mark that as a test we did not pass. You can go to your calculator again. You can select another random. You get 1, 2, 3, 4 correct answers. So that would again be another fail. So we'd go here and let's see if we can get one where we pass. Actually, here we go. 1, 2, 3, 4, 5, 6. So there'd be an example where I got 6 correct. So that's greater than or equal to 5. We passed the test there. And you could do as many simulations as you wanted and start to kind of see the more simulations you do, the more closer it's going to get to that actual experimental probability if you were actually guessing on all those tests. So you could continue to do more and more trials and start to select or find the probabilities of passing the test. You can also look on some of your handheld calculators. If you click apps and then scroll down to probability simulation, there's another way that you can simulate probabilities using technology. Lastly, we're going to look at theoretical probability. So theoretical probability is based on reasoning. It's what should happen if the experiment is conducted. So to calculate a probability, theoretically, you're going to reason how many event outcomes are in your favor compared to the total number of possible outcomes. And when we're dealing with theoretical probability, we're always going to want to find what the sample space is. So the sample space is the total number of outcomes that are possible for an experiment or activity. So it's the set of all possible outcomes. Sometimes when you're doing theoretical probability, you'll have equally likely outcomes. Like on a dice, there's 6 total sides. So each of those sides has a 1 out of 6 chance of landing up. That would be where you have equally likely outcomes. Or if you're playing the game of life, you have a spinner with 10 equal sections. There's a 1 out of 10 chance to land on each of those numbers. Down in problem 3, then we'll find the probability of each event. So here we have a number less than 3 on a roll of a fair number cube. So a fair number cube, we're going to have 6 total outcomes. And we can find then what's the probability of getting a less than 3. Well, we have to reason how many numbers are less than 3. There's 2 possibilities, a 2 or a 1, out of 6 total, which is going to give us a probability of 1/3. So 1/3 would be our chances of getting a number less than 2. Now, getting a sum of a number that's a multiple of 4 on one roll of 2 fair number cubes. Well, if we're rolling 2 number cubes, now we have 6 choices times another 6 choices. There's going to be 36 total outcomes. So using the counting principle from section 1, we'll have 6 times 6, which is 36 total outcomes. And then we want to find the probability of getting a multiple of 4 when we sum. So a multiple of 4 would mean that when you add the numbers together, they're either a 4, an 8, or a 12. So on the schedule, I linked a probability formula sheet so we can count up our outcomes. So here you have all 36 options when you're rolling 2 dice. So any time you get a multiple of 4, which is adding up to 4, which you have 3 outcomes there, adding up to 8, or adding up to 12. Those are all multiples of 4. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 total outcomes. So we'd have a 9 out of 36 chance, which would simplify down to 1/4. Other types of probabilities, we can get data presented in a table. So in a class of students, the following data table summarizes how many students have a cat or a dog. What is the probability that a student chosen at random has a cat or a dog? So again, we want to find the sample space. We got 15 students who have a dog. So I'm just adding up this row. 15 students who do not have a dog. You could also look at there's 5 students that have a cat, 25 that do not have a cat. So either way, you're getting 30. So you're adding up the total number of students. That means our probability is going to be compared to 30. Now we'll add up how many have a dog or a cat. So here we have students with dog and a cat. Here we have students with just a cat, and here we have students with a dog. So 12 is the only that have neither, so we're going to add up all the other values that have a dog or a cat, which gives us 18. Simplifying that, that would also simplify to 3/5. So there would be our chances of selecting a student and getting a dog or a cat. And lastly, in problem 5, we have a class of 23 students, so our sample space would be 23. 18 are female and 7 have an A in the class. There are 5 students who are female and have an A in the class. What is the probability that a student chosen at random is a male? So if we know we have 18 female, then that's going to leave us with the remaining 5 are going to be male. So my chances of selecting a male would be 5 out of 23. So we can get data in a paragraph format. We can start to make some conclusions, reasoning, and start to find that there'd be 5 total out of 23. So that wraps up section 11.2, and you are ready for trying some practice. You can go ahead and good luck, and we'll see you next time.